contarles qué fue lo que hicimos con estos sensores y a qué resultados llegamos. Y mucho de la intención era hacer algo para cualquier persona, aunque no tuvieran conocimiento de soldadura, de programación, absolutamente nada. Cualquiera se podría involucrar. Y más adelante vamos a continuar con una segunda versión de taller. Lo mismo, intentando que sea para cualquier público. Entonces, pues fue eso. Empezamos nosotros. A ver, ¿ya me deja? Ahí está. Em, eh, Primero, bueno, ¿para qué nos sirven los sensores? ¿No? Una de las principales razones que vamos a estar midiendo el aire son porque son cosas que no vemos, que están ahí presentes, pero no las estamos viendo si las respiramos y todo el mundo respiramos el mismo aire. Y nos afectan de diferente manera a cada persona. Un poco la idea del taller era hacer conciencia de eso. Entonces, con los sensores podíamos medirlo y luego podíamos analizar los datos. Entonces, parte de lo que hicimos fue hacer toda la electrónica, parte de la programación y obtener todos los datos. Lo que hicimos fue desarrollar algo que durara por lo menos un día de grabación de datos y se obtuvo muy buena información. Utilizamos componentes bastante comunes. Por ejemplo, usamos un SP32, que es bastante común o conocido con todos los electrónicos, con todos los que por lo menos han hecho algún trabajo con programación básica. Un sensor este sensor utilizamos nada más como el 10% de lo que este sensor puede realmente hacer. Es un sensor Bosch que es multivariable y tiene una capa de Machine Learning con esa capa podemos reconocer qué tipo de gases está respirando. Y bueno, una batería porque es parte muy importante de este proyecto. Y bueno, todo lo que hicimos lo podíamos ver en el celular, porque la información no la podemos visualizar de otra manera. Hicimos que nuestro microcontrolador se conectara, o más bien que generara una web y el celular se conectaba directamente al controlador. Al final esto fue lo que hicimos. Hicimos un PCB con sus sensores y una batería. Después de conectar esto fue en el día uno, pasamos a la parte de fabricación. Entonces, hubo quien fabricó en MDF, como esta era la parte interesante, también había que guardarlo y protegerlo. Entonces, hubo quien diseñó en MDF. Hubimos otros que decidimos irnos por impresión 3D, que también es muy versátil, muy práctico poder hacer eso. Y después de este día, la idea era llevarnos los sensores y tomar mediciones en un mundo real. Hay que tener en cuenta que estos sensores son muy sensibles, muy susceptibles a cambios, vibraciones, pero de todas maneras nos dieron muy buena información. Hicimos bueno, les voy a mostrar dos sensores. Primero, lo que nuestros invitados hicieron, estuvieron en Santa Fe un rato, luego fueron a la Torre Latinoamericana y regresaron a Santa Fe. Hubo lluvia en algún momento, entonces eso también nos da un poco de idea de que baja presión estuvo presente. Y también pudimos ver lo que este sensor mide, que es la resistencia del aire. Y a mayor resistencia, este, mejor es la calidad del aire. Y lo vemos sobre todo cuando empieza a haber lluvia. Nosotros hicimos un pequeño modelo de índice de calidad del aire, nomás que para que nos diera un poco de información. Al final, estos son resultados que nos permiten ver ya eh, los que estuvieron presentes estuvieron revisando. Este fue algo completamente diferente. No, este no es el otro es este. No, ¿por qué me mueve? Ay, ¿o qué me equivoqué con? Ah, no, este es otro. Este fue en Parque La Mexicana, un alumno que estuvo aquí en Santa Fe durante buena parte del día. Luego se fue al Parque de la Mexicana y luego se fue a su casa que está por Toreo, fue lo que nos dijo. Y las mediciones son muy diferentes también. Con un índice de calidad de aire muy malo cuando se acerca a la ciudad. Entonces, la intención de este taller no era que hiciéramos un superanálisis de los datos, era simplemente poder darle sentido a lo que el sensor logra extraer pues, del aire que estamos todos respirando. Y finalmente, pues invitarlos que si hay alguien interesado, para finales de mayo, junio, tengo previsto hacer un segundo taller, pero con miras a un proyecto un poquito más ambicioso, que es monitorear en tiempo real, bueno, no en tiempo real, pero monitorear la universidad con este tipo de sensores y que nuestros nodos o quien estén midiendo sean los propios alumnos académicos que se lleven su sensor, midan por unos días o por unas horas durante el día y esa información la vamos a poder estar capturando y encontrar pues dónde hay más presencia de mal aire. También podemos integrar tal vez partículas, pero por lo menos podemos ver si hay buen aire en los salones cuando están en clases o cuando están en alguna otra zona. Y pues eso realmente fue nuestro taller. Entonces, para la próxima, los invito igual si están interesados en participar. Y para continuar, pues ahora sí le voy a ceder la palabra, bueno, primero a Jorge para que presente a la doctora Guita. Y yo paso a su presentación. Sí, déjame ver qué está pasando aquí para que me deje. ¿Dónde te sales? Aquí está. Ya. ¿Qué más al menú? Mm, mm.
Muy bien, pues muchas gracias, Dani. Muy interesante todo lo que hicieron en el taller. Voy a cambiar a inglés para presentar a la doctora Gita. I'm just gonna switch to English just to present Dr. Gita. Dr. Gita Rivaldi is a physicist and senior academic leader with extensive experience in research, higher education, and science policy. She's a professor at Riga Technical University and a leading researcher at the University of Latvia, with over 120 scientific publications in areas such as photonics, atomic physics, and environmental monitoring. Her career spans key leadership roles such as director of the Latvia Research Council, and she's also a member of the Latvian Academy of Sciences and has led numerous international research and innovation projects contributing to the advancement of science, technology, and higher education systems. So we're really happy to have Dr. Gita here. So now the floor is yours. Thank you very much for being here.
So it's possible to put here somewhere? Can you maybe help? Which? Like that.
Yeah.
Okay, can you hear me? Yes. Hello to everyone. I am so pleased to be here. Thank you, Daniel, you inviting me. So I'm very happy to be in Mexico. I like a lot. I like your university. As far as I have seen, the laboratories, they are impressive. So, and something about what we are doing. And also, I will start with my city and with my country, because I'm not sure that everybody knows where we are located. We can see here is a Baltic Sea, and and here is Latvia. This is Estonia, Lithuania, and somewhere here is Sweden. Somewhere here is Norway, I think, and here is somewhere Denmark, where my co-worker is coming from, because she's also involved in Riga Technical University, but living in Denmark, in Copenhagen. So our capital city is located here, and it is Riga. Does it? Oh yeah, it's green. No. Okay, doesn't matter. This is our capital city. That is an old city, is Hansa style. And the historical center of Riga is also in UNESCO as one of the world's most important cultural and archaeological sites. What you can see here is our main church. And here is some kind of very huge singing festival happening every fourth year. My university is one of the oldest and biggest interdisciplinary universities, founded in 1862. Now we have about 15,000 students, about 50 study programs in English. So about 4,000 international students right now. We are working so hard to attract students from everywhere. Now we have 3 campuses. The main campus is in Riga, but we have government policy to merge some regional universities to make as a branches of this main university. Now we have branch in Liepāja and also one branch here, other side of Latvia, Rēzekne. So quite huge university. We have also 2 secondary schools, one international and one engineering high school. This is our library with 1.5 million items. Here you can see our campus from the top. Here, this is island called Kipsala, and on this island, all these buildings belong to Riga Technical University. Partly I'm involved only in research in other university, Latvian University. It's located also in opposite side, but you can see it also here. So this is our main river, Daugava, dividing our capital city in 2 parts. About faculties, we have every engineering discipline, faculty of civil mechanical engineering, natural sciences and technology, computer science, information technology, energy, engineering, economics and management, some social, economic sciences, architecture and design, and also now Latvian Academy of Maritime things is merged into the Riga Technical University. As well, business school, yeah, and I mentioned already we have this branch in Liepāja and Rēzekne. Yeah, we are also happy to have the same as you have, nice design laboratories where students can do their own stuff by 3D printing, laser cutting, and plotting everything we can make with our hands. And also I want to mention this is Curiosity Center for Children, because we think it's very important to raise interest in sciences, in STEM, in science, physics, chemistry, because, you know, everybody wants to be a lawyer or I don't know who, but not so many students want to study physics, chemistry, natural sciences, but still these numbers are now growing. We work a lot to attract children. So myself, I work in Institute of Physics and Material Sciences. The main fields are material sciences, semiconductor physics, photonics, sensors, energy, and we participate in several study programs. One is the main of our institute is material science and nanotechnologies, also design engineering, and also PhD program, chemistry, material science, and nanotechnologies. Now about today's topic, about air quality. Since you have seen we are located close to the Baltic Sea, and maybe it's interesting for you, but we have also a lot of ship traffic, and ships are also not so nice. They are quite dirty, like cars. And we have strong regulations coming from European Union and from all these maritime organizations that we need to decrease the greenhouse gases emitted from the ships about 50% by 2050. And that means there is a lot of work, and to demonstrate it, you can see here, we have 7 ports in Latvia in general, but Riga port is very huge, Liepāja port is quite big, and Ventspils port. These are the main port and some smaller ports. So the places where the ships are coming, international ships, and here you can see the demonstration. This is this place here, and there is a Estonia island here. And this is quite narrow place where many ships are coming. You can see the routes from the ships making, back. Yeah, these are emissions from the ships coming every day. many of them. And yeah, and that they bring some pollution to the port cities because there are docks close to these cities. They are waiting for I don't know what, making traffic. So it's quite a lot. And it's yeah. We have done overview of the emission close to main cities like Riga, Ventspils, and Liepāja, and we did see that indeed there is quite a lot of amount of CO2, CO, SO2, and yeah, we want to preserve our nice beach, our nice sea to make it clean. I just put some pictures of Baltic Sea. It's nice, it's a bit cool, about 23, 25 degrees, not 30, but still, I think it's nice. Here is a demonstration. Here we can see some how often these ships are coming, and we can classify what kind of ships they are, shipping, fishing, or just pleasure type, or high speed, or cargo, or tankers. So there are a lot of these ships. And what we wanted to do, okay, there is some emission picture, how it changed over the years. It's decreased a bit over COVID time, but now it starts to increase again. So in general, the main pollution is coming in form of CO, COX, and N2O, NOx, and all small particles. These are indeed, I put some pictures here from NOx. We have goal. Seems to be that we reached, but still we need to monitor all these things to be sure that we can keep these goals. And we need to monitor, and we want to avoid dirty ships coming in our ports. And that was the main idea of our project. With the drone sensors, try to understand which ship could be allowed to come and which should be not coming. And yeah, this is our project. Our aim was to develop operational principles of joint land-based and mobile systems and test them in laboratory level to detect dirty ships and not allow them to come to the Latvian ports. And yeah, the main idea was selection of sensors because we need, they have different technical requirements, then to make them in integrated IRL, this UAV, meaning that is a drone. The longer name of the drone is unmanned aerial vehicle. Yes, that is simple, in simple words, drone. And then we wanted to do it such a way that the drone itself finds a ship via computer vision with a computer artificial intelligent algorithm that it can detect where the ship is, go around and measure this and sniff and measure SO2 and CO2 ratio. That means we need to include also these sensors on the vehicle. So here, and there should be also land-based operation center, which would monitor and give commands to the drone. Yeah, and here you can see our prototype. Finally, we got it ready. Was not easy because it's a very huge, complex task, and the time was not so long given for this task. We chose 6-motor hexacopter. You can see it here. It has 6 motors. It was chosen due to their possibility to carry all payload, as well as to keep the flight time quite okay to reach the dirty ship. Yeah, that is a drone, and we put on the drone computer vision controller implemented using Raspberry Pi 4, as well as this emission measurement unit that we started only with CO2 and with SO2 and CO2, since we use the sniffer principle, first to check if they have good fuel. And yeah, and the data should be packed and transmitted to the coastal, this control center. We use LoRa P2P system to send the data. Here you can see our small sensors. I know Daniel likes small sensors. We use different, we use small and big, and this time we use small sensors because this drone cannot carry a lot of heavy sensors. One was for CO2 non-dispersive infrared technology, meaning that it sucks gas in and then measures the concentration. For this SO2 was difficult to find good sensor, but we found some. We made some dead, broke some, but one was okay. And we use this sniffer principle. We measure ratio SO2 to CO2. And this is some kind of regulation coming from these international port organizations. And only 3 ppb per ppm is allowed to have in the plume of the ship. Yeah, and we did some tests in small port because we faced very huge difficulty to organize the test in Riga port because Riga port is huge port and they're afraid to have drones there. Now everybody afraid to have drones because of our neighbor Russia and everything that happens between Russia and Ukraine now is drones. Now, yeah, and therefore we had agreement with small port, Maastricht, in Kurland, and we did experiments with a small ship. And yeah, we tested that we are able to measure the CO2 and SO2 ratio. In this case, the ship used very good fuel, and there was actually zero of the SO2 emission. Maybe not good for testing, but it is a result. Yeah, that was our nice project with the drones and some maybe future prospects and other activities, what we plan to do. We definitely need to continue these experiments with our sensor platform. What we didn't reach full plume recognition using computer vision because it's a very complicated task. What we did reach is we elaborated algorithm, then the drone flies around the plume, around the ship, and use some kind of multi-point sensing, not detect the whole plume. We detect only the ship by computer vision because plume detection is very complicated and there are many projects running now also at the Europe level and people spend years to make it in good way because winds, everything matters. When wind is from one side, plume goes that. So everything that comes out of the ship. Therefore, we use simple algorithm that it just collect the air from around the ship, not exactly detecting the plume. So we need to continue here. We have 2 project applications in Europe. In Europe, we have this common pot system. Every country pays money in, and then we do joint competition and try to get money out. And for this, we need several universities participating. Also, I think Mexico is allowed to participate under some calls, under some conditions, because there we need special agreement, and sometimes European Commission do some special agreements with other countries. So I see here maybe we could cooperate in future. And yeah, we would like to continue this. And what else we do? Me as a physicist, we try to be involved everywhere where people need devices and our knowledge. You can even remember X-ray was invented by physicists, yes? And now everybody in medicine use it, as well as tomography, all these things. So now we have an actual project, quite huge again, together with other universities. It is peat and water analysis in Latvia's Petland restoration program. Petlands is a sump, yeah, where a lot of water is, and yeah, now we need to restore it because we get peat from there like product, and now Europe says enough. Now you need to do something else, and there's a huge program. We measure greenhouse gas emissions from there. It is mercury problem there, and also microplastics. For mercury, we are quite fit, and we can do it at a very good level, 2 nanograms per cubic meter. And we are also involved in microplastics with Raman spectroscopy. So that is one of directions being active now. Indoor air quality, we are now involved in the project for removing all bad things from the rooms, not only measuring, but also how to get rid of them. And we are involved in the removing biological, like bacteria, viruses with UVC light and ozone. Therefore, I need some assistance consulting about ozone detectors because we have quite bad experience. So we even think that we need to elaborate our own sensor. Yeah, we do also, what we do is we make UVC sources with metal vapor discharge, and we try to find maybe some good wavelengths for killing more effective than the common used mercury lamps with arsenic, cadmium, thallium, indium, nice colors. And yeah, we still are working on VOC sensors, small and big. My colleagues are working to make these nanocomposite sensors starting from scratch, from materials, and we use also a bit more bigger sensor, like put on the table with laser spectroscopy to measure very precise in real time. It can be used to measure like acetone, benzene from the breath. For medical purposes, people just exhale in the bag. We put in the absorption cell here, and and then it is detected at level 1 to 2 ppm, how many people exhale acetone, for instance. It was meant to elaborate system for biomarkers for lung cancer, for instance. So these are future prospects, and maybe you have some questions. I wanted to make some advancement about, I was invited and I agreed due to our this new program in PIT, Latvian Restoration Program, because this MDPI offered to be guest editor for Environmental Pollution Monitoring and Control journal. And maybe you are interested because it's quite okay journal. It has impact factor Q1, general instrumentation, general engineering instrumentation, fluid flow, blah, blah, blah. And also multidisciplinary, it is a Q2. So, and the deadline of this journal is, was here somewhere. 20 November. Yes, maybe it's interesting for you. There are actually, our university is a bit skeptic about these MDP journals, but myself, I think they are quite good. So there's very fast publication time. Yeah, I think it's nice to have it. Yeah, thank you for your attention, and maybe you have some questions. You can ask Spanish, somebody will translate. Okay.
Good. First of all, thank you very much for the interesting presentation. I have a question. So you're using these drones to measure the pollutants, right? The
Yes.
particulate matter.
No, right, yeah, in general, yes, in future also PM. Yeah.
Okay, so these different components of air.
Yeah.
So what happens, or have you considered what happens with the air that's pushed by the rotors of the drone? Or is it negligible and it doesn't matter, or are you compensating that?
Yeah, we did experiments before putting, letting it fly over the ship. We did experiments at the laboratory, making big ventilator and measuring at what distance that is safe to or undisturbed, the values are not influenced by the wind. And now we take it into account, this factor, yes.
It's compensated.
It is not compensated, we just try to fly from other, well, I can say it's compensated somehow.
Perfect, thank you.
Okay, thank you for your presentation. Usually the electrochemical sensors, they have some, you need to compensate against temperature and humidity. with your algorithms.
Mhm.
So are you doing this on your device or in the platform itself once you stream the data
Mhm.
to whatever cloud you're using, or
Mhm.
can you explain us on that?
Yeah, as they measure also not only SO2, but also temperature, pressure, humidity, what we measured yesterday here. It is taken and it is calibrated and made it through this whole land-based system. We receive data and then it is then taken into account. Yes, so that was actually, it still needs some elaboration, because I would say that our first measurements, because also the vibration is important, and also there are a lot of questions still.
Yeah. No, but that's good. Yeah, thanks.
Yeah.
Who else? Dani?
Now many projects are running, trying to do similar things, and therefore we also want to be included in bigger European project. I know exactly, we have talks with Copenhagen University in Aarhus, they have branch, and yeah, there will be projects that make bigger drone systems, having more gases. Yeah, but there is again the problem that the drone itself is too heavy, and then the typical problem is that you need a man in a boat. So the like distance, yeah, it's like man controlled. And our idea was to try to do with computer vision. We are still not ready, so we need to continue. This task is very complicated.
Okay, thank you very much. Just a quick question. Are you planning for the drone to detect the plumes and then the drone fly by itself and do the circling around the boat?
Yeah, initially that was the idea, but then we decided it is too complicated for our project duration, and now we detect the ship. The artificial intelligence algorithm, I didn't include it there because it's huge mathematics. And not me is doing, my colleagues are doing this algorithm. They are trained on ship detection. They can detect ships, and then plume detection is not included because it's too complicated. We just detect the ship, and the drone flies around the ship and takes the ratio in different points. In general, when they don't fly very far from the ship, we see if it's dirty or not, because if this value is over the limit, you can see it instantly. And then was the idea that now then send a warning at the land, and the land invites some guards coming and saying, no, no, no. And the future idea is also to put a land station. Actually, it was the initial idea that we integrate both one bigger land station and this drone only after the land stations see that the ships are approaching. We are thinking to put a land station at Kolka Lighthouse, which is quite close to the place where the ships are coming. So, but for that, again, we need financing and cooperation with industry and with local municipalities. And yeah, but that was the main idea, that we combine land station with drone.
How easy it is to work with the local authorities? Like, do they open the doors and say, yeah, go, come on?
Yeah,
we
we had experience that it's different. We have very good connection with local maritime organizations. There are several. In general, we have support from Riga Freeport, which is the biggest port, but they would not allow us to go and to fly with drones. We were able to agree them to take part in one project application together with Denmark, where they could be test place for the already bigger drone system, but would be made in Copenhagen. But unfortunately, this project didn't have success. So let's see if there will be next project. But for our case, it was difficult to agree that we will go with a drone in the airport. Therefore, we agreed with small authorities. And since we have people from Riga Maritime Academy, they have good connections with all these ports. And they had good connections with with the head of Merstraks port, which is really small port. And yeah, we can use these places, but not bigger ports. And Mara tried a lot to take contact. Maybe you come answer about the Aarhus port, no? That was very difficult. She called a lot, many times, and not possible. And also this institute in Copenhagen, people said that they cannot contact big Danish ports. It's nearly not possible. Therefore, all of this bigger European project that included many countries, they could include universities, but they could not to include like ports from Denmark, ports from Germany, very difficult. But therefore, Riga port agreed. So in comparison with these ports, our ports are easier to speak with, yes.
Thank you.
Okay, thank you.
Thank you very much for the
Thank you.
interesting presentation. Just as a small recognition to have certificate for your participation in the seminar and also for imparting the workshop that we have this week. So just a round of applause to Dr. Kita.
Thank you. Thank you a lot.
And well, muchas gracias a todas las personas que nos vieron en línea, en Zoom. Nos vemos para el siguiente seminario. Ahorita nos vamos a tomar una foto, igual si nos quieren acompañar. Also, we're gonna take a picture.
Picture. Okay.
Yes. So,
Remove this.
¿cómo le quito el